still having a few issues with the computer, but we're going to persevere. 4.4, bearings. What do we need to know about bearings? True bearings are measured from true north in a clockwise direction, and they are written using 3 digits, always a 3-digit number. Opposite directions differ by 180 degrees is another little thing. So you can see, for instance, northeast is 45. We add 180, we get the opposite direction, 225. In the same way, northwest, 315, opposite direction. You don't want to add 180 because you'll be over 360, so you subtract 180. 135 is in the opposite direction. Works the same for all reverse bearings, back bearings, or opposite direction bearings, as this book chooses to call them. Very simple, 3-digit number, measured in a clockwise direction. So we're going to have a go at a few here. For each diagram, give the true bearing from O to A. So from, we're starting in position O and going towards A. It could also say of A from O, same thing. Just get used to the different wording. By the way, this first one's very easy. We've gone in a clockwise direction, 50 degrees from north. So the bearing for A is 050 degrees. Now, you'll note up there before, they've got that degrees T, that's for true north, although we're always going to do true north in this one. It's not a bad practice to get into the habit of putting your T there afterwards. Let's have a look at B. Well, the bearing is actually going to be the angle from north around to A. Don't get sucked into that 30 degrees. But what we can do is figure out that that angle must be 60 degrees. So whilst the angle is 60, the bearing is 060 degrees true. 3-digit number measured from true north in a clockwise direction. Let's have a look at C. We've got a 49 degree angle there, and we've got a 90 degree angle there. So we've got to add those two together to get a bearing of 139 degrees true. And finally, we've got 180, and then we've come back 18. 180 minus 18 is 162, so I've got 162 degrees true. So finding an angle is not particularly difficult. Finding the bearing, you just work out how far it is from north and write it in. Where might we use these sort of questions? Let's make this a little larger and have a crack. For this simple map, find the following correct to one decimal place. How far west is point A from O, and how far south is point A from O? So you can see there, we've got a right-angled triangle. And that's what we're going to do. We're going to reproduce that right-angled triangle and figure out, using a trigonometry, what those distances are. So how far west, that's going to be that part A is going to be that distance on there. Part B is how far south, it's going to be that distance there. Use the relatively average drawing there. And we've got one distance, we've got 4 kilometres. And we've got one angle though, we've got that being 65 degrees. So, we want to go ahead and label our triangle, because that's the first step to solving any trigonometric ratio problem. So we label the hypotenuse opposite from the right angle. The angle we know, so this becomes the opposite side, and adjacent is the side that's next to it. I'll just use capital A and capital O for, actually I might use op O because that gets confusing with the 0. To work them out, so for part A, I need the rule that relates adjacent and hypotenuse. If you can't remember, you write it out. SOHCAHTOA. And you can see the rule that relates adjacent and hypotenuse is cosine. So I write out my rule. Cosine theta equals adjacent over hypotenuse. Filling what we know, cosine of 65 equals adjacent over 4. 4 cosine 65 equals adjacent. Last thing you have to do is push buttons on your calculator to get the answer. I will do that in a second. Part B. How far south is it? I want to find the opposite side. So which one uses opposite and hypotenuse? It's sine. Sine theta equals the opposite side divided by the hypotenuse. Fill in the blanks. Sine 65 equals the opposite side divided by 4. So I've got 4 sine 65 is the length of the opposite side. And now all we need to do is get a calculator out and we'll be right. I'm going to go to my trusty Desmos, because I find it a bit easy to use in the built-in calculator on the computer. I think if you're stuck doing it on the computer in class, Desmos is probably an easier way to go as well. Just check my settings and make sure we are in degrees. You need to do that on your calculator too. So now I go for cosine 65 degrees, 1.69. That's approximately equal to, so I'll make it 1.69 kilometres. We've got my beautiful approximately equal to brackets. These are both going to be approximations, so I should do the right thing. Now this time I don't want cosine, I want sine. So my length 3.63 to 2 decimal places. So 3.63. Looks pretty good to me. Double check I wrote it down correctly. Kilometres. And then you could go ahead and, given that they wrote the question in words, nice and polite to answer them in words. So how far west is point A from O? A is 1.69 kilometres west of O, and A is 3.63 kilometres south of O. Essentially all the questions in this chapter are going to work like that. I don't think you'll have too many troubles. Good luck, and we'll see you in the next video.